So in the spirit of exponentials, here's the pattern that you can think about when you're looking at the numbers in a log expression. So remember how the hint I mentioned in the previous video is that logs are related to exponentials? This is just a rearranged exponential expression. 2 as a number to the power of 3 is actually 8. So the pattern actually is that this number as the subscript to the power of this number after the equal sign gives you an answer of the number in the middle. So I like to use that little loopy arrow thing to kind of show the order in which I just thought about those values, but that's the only way you can tie together those three numbers with any sort of math that makes sense. 2 to the power of 3 is 8. And, not coincidentally, that pattern actually works for all of these. 3 to the power of 3 is 27. You could actually rewrite those numbers or just do it in your head. And 3 to the power of 3 really is 27. If I do the exact same pattern in the next one, 5 to the power of 2 is 25. So that little loopy arrow is just kind of reminding me of the direction. But if I grab those numbers and just rearrange them in this order, I can see that they work. So in the last one, 10 to the power of 4 is 10,000. And now I can tell that pattern is completely consistent. That the number at the bottom, or the subscript number I should say, to the power of the number after the equal sign gives us an answer of the number in the middle. So as I'm looking at this empty box underneath, I can say to myself, okay, 2 is supposed to be like the base. So 2 to the power of something, it looks like we don't know that yet, is equal to an answer of 4. So the question is, 2 to the power of what would give me 4 as an answer? And I think about my numbers and I can think, oh, okay, that's 2 to the power of 2. So the pattern itself is always going to be in the same order. We just need to figure out what number will complete the pattern. So in this case, 2 to the power of 2 gives us 4 as an answer. If it helps you to draw that little arrow thing, definitely do that, because some people find it really useful. I'll think about it with the next one as well. 2, which is my base, my little starter number, subscript starts it off, to the power of something, I'll leave the box there because I don't know what that is yet, is going to be equal to 32 as an answer. So 2 to the power of something would be 32. And I can think about my powers and realize, maybe with a calculator to help, that 2 to the power of 5 is 32. So 5 must be the number that goes in the box. In the next one, notice how this time the box is in a different place. I don't know what number to start with, but that subscript is always the thing that starts me off. So notice how the box is a little bit smaller and lower than it usually is. That means something to the power of 2 has to give me an answer of 100. So now I'm again going to think about this. Something to the power of 2 is going to have to give me an answer of 100. So I'll draw the box and I'll ask myself, well, what number could go in that box? What squared is 100? If we think about it, we can realize, oh, that's 10. 10 must go in the box because 10 squared is 100. So a little bit of common sense or mental math can help. You can always use a calculator if that helps, but hopefully you're starting to see the pattern. And I'll write the pattern down this time as I draw the arrow so you can see it for yourself. 5 is the subscript. That's always where we start. So we start with the subscript. Raise it to the power of 3. So the number after the equal sign is the power. And then the result, or the answer, should be the last value, which in this case is the missing one. So we start with the base. We raise it to the power of the number after the equal sign. And the answer is that middle number. So in this case, 5 to start to the power of 3 is equal to whatever number was supposed to be in that box. That's like our final answer. So I think about this, 5 to the power of 3, well, you can do that. That's 5 times 5 times 5, and that would be 125. So we know that 125 goes in the box. Now that you've kind of seen the pattern, try the second row of numbers and see if you can figure out, either by guess and check or using a calculator or whatever combination of techniques works for you, what numbers go in these boxes. You can use the ones I did as an example, but I'm going to give you some time. If now you can do the second row and check your answers using the answer key that you can find in the learning plan. Once we get some answers there, then try in number 3 to describe the pattern in your own words. I always describe the pattern kind of algebraically, like you saw I did here. I try to describe with arrows and a visual. So try to put this in your own words in question number 3 in a way that makes sense to you. If you're not sure what to write, you can always look at the answer key and use that as an inspiration, but hopefully that'll give you some time to kind of process the connections between these numbers and the order that we connect the numbers, so that when we get to the next section, you'll have something you can look at, almost kind of like a little bit of notes to help you remember what we talked about in this video.